In problem 7.14, we are given a picture of a yo-yo, like I drew here, with actually an x-axis right here. That is rotating or going down, and we have to prove that the acceleration is actually equal to 2/3 times the gravitational acceleration. So now what I decided to do actually is to take the beginning of the x-axis at this point here, and it goes down. So I can say that the potential energy at point 0 is equals to 0, and the potential energy is actually negative mgx, because as it keeps going down along the x-axis, the potential energy actually becomes negative. Therefore, we kind of want to go back to initial position, when its position is the position that is at right now. Okay, so now I need simply to write down the kinetic energy, which is equals to 1/2 mv squared plus 1/2 iw squared, as given by the book. Now, the book also tells us that I is equals to 1/2 mr squared. And we know instead that our rotational speed is equals to our velocity over the radius. And of course, when we have our rotational speed squared, it's going to equal to velocity squared over radius squared. So if we plug in everything in here, we're going to get our kinetic equation. The kinetic energy is equals to 1/2 m. Instead of v, I'm going to write x dot squared plus 1/2, and now substituting everything. So I is equals to 1/2 mr squared, and then w squared is equals to v squared over r squared. As you can see, the r cancel each other out, and out of this we obtain that is equals to 1/2 mx dot squared plus 1/4 m. Instead of v squared, again, I'm going to write x dot squared. Okay, as you can see, now we can simply do x dot squared, and then 1/2 plus 1/4, and this actually equals to, and these actually equal 2/3. Sorry, 3/4. My bad. So we're gonna have 3/4 mx dot squared, and this is our kinetic energy. So now our Lagrangian is equals to our kinetic energy minus our potential energy. Therefore, it's going to be equals to 3/4 mx dot squared minus negative mgx. Okay, so let's solve the part here. Is equals to mgx plus mgx. Okay, so now derivative of Lagrangian in terms of x equals to the d over dt, derivative of the Lagrangian in terms of x dot. So the first part, this first part will yield mg, and the second part will be d over dt of 3/2 mx dot. I already derived the first part, so this, oops. Okay. So out of this, I get that I actually want to cancel out the m already, because there's a constant, so it doesn't really matter. So I get g is equals to 3/2 x double dot. So as you can see already, x double dot is equals to 2/3 of g. And that is the final solution. Oops. That is the final solution to our problem. That is what we just proved, exactly what it asked us to prove. Okay, it doesn't want to work for today. There we go.